A question with period using milliseconds. These can be tricky. What is the period in milliseconds if the frequency is 100 hertz? And 5 choices. Well, step 1. What is the question? 1. Inquire. Make sure you understand the question. Here, I am looking for the period, so I use the symbol T to abbreviate that, as we do in class. And since the period is not required in seconds, but milliseconds, I need to remind myself, this is an alert for myself, that the period needs to be in milliseconds. M stands for milli, S stands for seconds. What's given is the 100 hertz. Well, the principle is F and T are related in a formula or a pair of formulas. I like to remember T is 1 over F, F is 1 over T. And since I need T here, I write it in the form T is 1 over F. I also note that 1,000 milliseconds is 1 second. I'm going to need that at some point. To apply, I use the equation 1 over 100, and that gives me 0.01 second. Think of this as 1/100th of a dollar. That's 1 cent, 1 penny. Well, I need to relate that to milliseconds, and I remember that 1 second is 1,000 millis. The millis are small, they're tiny. Each milli is 1,000th. So a millisecond is 1,000th of a second, so I need like 1,000 of them to get 1 second. So I replace the 1 second here with 1,000 milliseconds. And here, if I want 1/100th of 1,000, the answer is 10. Or I can simply move the decimal point over here once for every factor of 10. If I move it over twice, then I can kill off 2 zeros, and I have a 1 there, 1 times the 10. So either way you like to look at this, you can write this as a fraction if you want, 1 divided by 100, and then cross off 2 zeros upstairs and downstairs and get your 10 milliseconds. Well, is that reasonable? Does the answer make sense? We have 10 milliseconds for 100 hertz. Should I pick 10 for the answer? Well, what would it be if T is 1 millisecond? I want to just reflect on this, look at this from a different angle, because 1 millisecond is kind of an easy question. 1 millisecond, that's 1,000th of a second. That means you're doing a thing 1,000 times a second. So for 1 millisecond period, the frequency is 1,000 cycles per second, or 1,000 hertz. Then if I were to drop the F down, I know that when F goes down, T should go up. So that means T has to be greater than 1 millisecond. And if I do only 100 instead of the 1,000, like 1/10 the amount, then it should be 10 times longer. So 10 times longer than the 1 millisecond is 10 milliseconds, and it checks out. So I feel confident here that the answer is C, 10. Now I recommend something here. We know that T is 1 over F and F is 1 over T, and that's when you have the regular cases of seconds and hertz. But milliseconds comes up from time to time, and I think it's worthwhile to remember sister formulas to these. If you want T in milliseconds, then it's 1,000 over F, because the milliseconds are smaller. See, if I do this calculation and say the answer is 1 second, because F is 1 hertz, then 1 second translates to 1,000 milliseconds. So if I want the formula to give me milliseconds, I use 1,000 over F. I think it's easier to remember this pair of formulas where we can swap the T and the F. Here I'm going to swap the F and the T. So T in milliseconds is 1,000 over F. F is 1,000 over T in milliseconds. That helps rather than playing with decimals. If you don't mind playing with decimals and doing all that, then this is sufficient. You don't need this, but I'm suggesting this as sort of a technique to have this like a different size tool. You can get the job done with this tool, but sometimes it's more convenient to use this size. So then for F is 100 hertz, I would go right to this formula. T in milliseconds is 1,000 divided by 100, and heck, 2 zeros, 2 zeros cancel. That's 10. 100 goes into 1,000 10 times. I'm finished. Answer super fast and leave the exam early.